Okay. So here is the strategy we should use. If the rational expression f(x) equals px over qx, where px and qx, they are both polynomials, and if the degree of the px is less than the degree of the qx, so when this is a type 1, and we factor the qx, the polynomial qx, into a product of some linear factors, right? Into some linear factors. And suppose the exponent of each linear factors is this m1, m2, up to mn. So m1, m2, mn, they are some positive integers. If they are 1, that means the linear factor is not repeated. If these are greater than 1, then we're going to have some repeated linear factors. Then the pattern we're using is like this. So for the first factor, for the first linear factor, we're going to generate how many? m1 fractions, right? And plus, for the second linear factor, we're going to generate m2, this number of fractions, and all the way to the last linear factor, we're going to generate mn, this amount of fractions. Okay. And after that, you need to solve for each number. You need to determine what are a1, a2, am1, and all the way to capital N, mn. Okay. Like in this example. Okay. So this is our px, and this is our qx. Now the degree of the px is 2. The degree of qx is 3. Okay. Now first, we factor the qx. Now to factor this polynomial, since we notice that every term has x, so we can factor out a x. And then next, we try to factor this trinomial. Now, if you find that you are not able to factor the trinomial, in other words, if this trinomial is irreducible, then we call this trinomial as a irreducible quadratic factor. And in my next video, I will show you what do we do when we have a irreducible quadratic factor. But here we can factor this trinomial, and we can factor this into x plus 1 times x plus 1, which is x plus 1 square. Now, after we factor this this polynomial, we notice that here we have two linear factors. One is x, and this is a non-repeated factor because the power is 1. And another linear factor is repeated, right? So this is like x minus 0. This is x plus 1. So we can rewrite this rational expression into a over x, right? So this fraction is for the first linear factor, and plus b over x plus 1 plus c over x plus 1 square. Now these two fractions, they are for this repeated linear factors because we have this exponent too. So we have two fractions. Okay. And then next, to add them together, we're looking for the least common denominator, which is x times x plus 1 square. So for the first fraction, I need to multiply x by x plus 1 square. Therefore, I multiply a by x plus 1 square. For the second fraction, I need to multiply by x and by another x plus 1. So I multiply b by x and by x plus 1. For the third fraction, I only need to multiply by x, so I multiply c by x. Now, if we compare this numerator and with 5x squared plus 20x plus 6, we will be able to solve them for a, b, and c. Okay, let me show you how to solve this. So one way, the traditional way is to use a system of equations, right? So if you want to use a system of equations, you need to simplify this numerator, like you multiply x plus 1 squared out, and you distribute bx into x plus 1. And then you combine the like terms. So combine the like terms, ax squared plus bx squared, and 2ax plus bx plus cx, and and then we compare the coefficient for x squared, x, and this constant. So we see a plus b must be equal to 5, right? And 2a plus b plus c must be equal to 20. And this constant a must be equal to 6. And use this system of equations, you can solve for a, b, c. Okay. Now, also we can use the way we can use some special numbers and plug in them into this expression. So for example, we notice that b, c, they both contain x, right? So if we let x be 0, if we let x be 0, on the left hand side we have a 6, and the right hand side we have a times 0 plus 1 square, and plus b times 0 plus c times 0. So we can figure out a equals 6, right? And then next, if we let x be negative 1, then a and b, these two terms will be 0. So the left hand side is 5 minus 20 plus 6 equals a times negative 1 plus 1 square. So this is 0. Plus b times negative 1 times negative 1 plus 1, this is also 0, and minus c. So by comparing c and these numbers, the sum of these numbers, we can see that we can have a negative c is equal to negative 9. So c equals 9. Okay, once you find a and c, you plug in a and c back to this expression, you can find b.